Yeah, I guess I should stay here. Thank you. So here I am again talking about Bell's theorem, but this time I'm going to be shorter, and I'm going to be concentrating on what are the assumptions behind Bell's theorem in very general sort of terms, and in particular using terms related to causation, because I've been led to understand that that's of interest to Buddhism. And then I want to end, so as a follow-on from Ian's talk, to talk about how different interpretations of quantum mechanics that Ian talked about react to the possibilities. So just to, okay, so this is the outline. I'm going to begin by very, very quickly reviewing Bell's theorem, putting in a little bit of context and talking a little bit about the controversies around it. Then I'm going to just give my own list of 6 assumptions. So I think the abstract says 7, but I've simplified it to 6 assumptions, which put causality in the center of considerations. And then, as I said, get on to the interpretation. So context and controversy. Okay, so why should you care about Bell's theorem? I said a little bit about this in my last talk, so people think it's important, okay? Physicists think it's important. So here's a quote from Philip Stapp, 1977. Bell's theorem is the most profound discovery in, it's a Henry Stapp. Henry Stapp, yeah. Henry Stapp. Bell's theorem is the most profound discovery in science. Okay, so I wouldn't go quite that far, but I did go this far. So this is from my own paper in 2014. Bell's theorem is the most profound ramification of quantum theory that has been experimentally confirmed. I believe in that. Okay. Okay, so to remind you the general setup, we have 2 parties, Alice and Bob. So this is what we call a space-time diagram. So time often in physics show increasing as we go up, and space is just along this way. So here, this is Alice's lab. So it's always at this point in space, but time goes up here, and this is Bob's lab over here. So first Alice, before getting her outcome A, Alice has to make a choice of what to measure, so we call that the setting choice, and likewise Bob over here making a choice Y and getting an outcome B, and we're interested in the case when they, that's not quite what I wanted, interested in the case where the measurement which Alice is making is a measurement on one half of a pair of entangled particles, okay? So we typically have a source of particles down here, one particle goes there, another particle goes there. So these green lines show some, sort of where you would obviously expect to have influences taking place here. And what we're interested in is the correlations, as I talked about before. After repeating this experiment many times, the parties can get together and look at the correlation between X, A, B, and Y, all of those things together. And so the obvious way that you would think that what would be relevant here is that the particles going from the source to the outcomes here would have certain properties that we might call alpha and beta here, and then that's going to explain the correlation. Okay? And so this is exactly what Einstein thought. If there are correlations between Alice's and Bob's results, then they can be explained by some properties carried by the particles from the common source to the detectors. So that's Einstein there. And then Bell says, Einstein's belief is provably false for certain sorts of correlations which quantum mechanics predicts and which have now been observed. Okay, so that's Bell's theorem in loose terms. All right. So we can be more precise, and I'd say it's better to be precise, but then it's also more controversial to be precise. So I just wanted to flag the fact that what I'm talking about here, there will be people who will disagree. Okay. So what I'm going to do is give you a list of what I'm going to claim are reasonable assumptions that leads to a contradiction with the experimental results. Okay? And they're going to be fairly precisely labeled or precisely formulated assumptions, but the controversy is that different scholars, so physicists and philosophers, will disagree over what's the best list to use, or even whether a given list is actually correct. list, whether it's complete or whatever. But anyway, I'm just going to give you what I think is a useful way of thinking about the problem. So here we go, my list of 6 assumptions. So assumption number 1, experiences are objective. So an event observed by an agent, so we could think of that as being a person, maybe an animal, maybe any living thing, maybe even just a machine like a computer. Any case, an event observed in that sense is a real single event and not relative to anything or anyone. Okay, so the point is that there are some interpretations of quantum mechanics, which Ian touched on, that will deny that, okay? And I'll talk in more detail, later on about which ones those are. So all of these interpretations, all of these assumptions are sort of things that can be questioned. Okay, so assumption 2, causes are in the past. Okay? So if an event A has a cause, then that cause must be an event in the past of A. So this, again, this is something which some physicists reject. And I think the word retrocausality was mentioned in a slide in somebody's talk earlier in this conference. So there are some physicists who really believe that it's possible for a cause of an event to be in the future of that event rather than the past. So to get a contradiction, we have to make this assumption. So another important point I want to make here, I put this word cause in yellow here, obviously to make it stand out, but because I'm not actually defining what a cause is here. So I'm using the word without really giving it a definite definition, because I'm going to use it often enough that it's still going to lead to logical consequences, even without my having to give a definite, say anything else about it, basically. So of course there are many things that can be said about causes, and Buddhism has many things to say about causes, but to get a contradiction here, we don't have to add anything to what appears on these slides. Assumption 3, nothing goes faster than light. So this was Einstein's theory. What he definitely held to. So more formally, the influence of a cause cannot propagate faster than the speed of light, which is 300,000 kilometers per second. Okay, so I mentioned in my earlier talk that the speed of light is very fast. That's how fast that is. That's really astonishingly fast. 1 second, 300,000 kilometers takes you a third of the way to the moon or something. So it's extremely fast. Okay, so Einstein believed this, but does that actually make it a reasonable assumption? Well, I would argue it is, because we have very good experimental evidence that it's impossible to send a signal faster than light. Okay, that's one of the probably best established principles in physics. But I do want to point out that that's not the same thing as this assumption. So the assumption that we can't send a signal faster than light is not quite the same thing as saying that the influence of a cause cannot propagate faster than light. So it makes this reasonable, I think, but it doesn't mean that it doesn't actually imply it. Okay. Assumption 4, free choice is possible. So an agent, which remember could be a person, or maybe we'd allow it to be a computer or whatever, can make choices that are free in the sense of having no causes. Okay, so that sounds like a very strong thing to say, but we don't really need it to be that. What we really need is just that the causes for the choice that the agent makes are irrelevant to the experiments the agent performs. So there are some people, a minority, small minority, but including some very well-known physicists, who think that for some reason the free choices we make out of our heads, or however we make them, for some reason are actually have causes which are related to the quantum particles that we're making experiments on. Personally, I think that's a completely bizarre way to think about the world, but it is an assumption that we have to make, and it's an assumption that some people question. Okay, assumption number 5. Correlation implies causation. So that's something that people often tell you, don't make the mistake of thinking that correlation implies causation. Okay? But I'm using it in a very particular context here where I think it is actually a reasonable assumption. And that is in the context of having a repeatable experiment. So a very controlled environment where we can actually repeat an experiment and see a correlation in a reliable sense. So it's not just a casually observed correlation, it's actually repeatable and predictable. So in a repeatable experiment, if two events are correlated, okay, then either one event is a cause of the other event, or two, there must be a common cause of both events. Okay, so that's, so to give you an example, so let's consider an experiment which consists of choosing people at random from a population in some country and examining their lungs and examining their fingernails. Okay, and so what we might find is, oops, so let's look at this one up here. So what we're looking at is, do the people have yellow fingernails or white fingernails? Do they have diseased lungs or healthy lungs? Okay? And what we might observe is that there are many people with diseased lungs and yellow fingernails, and there are many people with healthy lungs and white fingernails, and there are some people who have diseased lungs and white fingernails, and there are some people who have healthy lungs and yellow fingernails. Okay? But if you look at this, I think you'll see that you would, hopefully it's intuitive to you that there is a correlation, okay, this is the word we use for situations like this, a correlation between having yellow fingernails, well, just in general, there's a correlation between fingernail color and lung health, but more specifically, the correlation is such that diseased lungs and yellow fingernails are correlated and healthy lungs and white fingernails are correlated. Okay, so if we observe this, okay, so as opposed to if there were no correlation between fingernail color and lung health, we would expect to just get a whole lot of people in all of these categories. Okay, so knowing about diseased lungs doesn't particularly tell you anything about whether you have yellow fingernails or likely to have yellow fingernails or white fingernails, and etc. Okay. So, but if the situation is like this, where we do have a correlation, then what this principle that that correlation implies causation is that either diseased lungs cause yellow fingernails, or yellow fingernails causes diseased lungs, or there's a common cause. Okay, and you're probably guessing that that's what we would probably think. If you know a little bit about medicine, you probably already have some guess about what I might be going to suggest could be the common cause in this situation. Okay, but let's say we have in mind that there could be a common cause. What does that imply to say that there would be a common cause? And so this is assumption number 6. And I should say that that stuff about smoking and fingernails has nothing to do with quantum mechanics, okay? Quantum mechanics has nothing to do with why people get yellow fingernails or diseased lungs or whatever. Okay, that's just trying to explain the concept of correlation and causation. Okay. So, what does it mean to say that we would have a common cause? Okay, and so this is assumption number 6, which says a common causes decorrelate. Okay, what that means is an event can be the common cause of two other events only if taking into account the common cause removes the correlation. Okay, so that might sound a little bit strange at first. Okay, but the idea is that we have a correlation, and the sense in which a common cause could explain that correlation is if it actually gets rid of it. Okay, and again, so I think I can explain that most easily with this example. So here, this is the table that we have, the correlation between fingernail color and lung health. So if there were so you probably guessed that I'm going to suggest that smoking might be the common cause for this correlation. Okay. How could we check? What would it be? If we would, so according to assumption 6, it would mean that taking into account smoking would remove the correlation. And in the sense like this, that if we separate our people now and ask them a third question, or we examine their fingernails, we examine their lungs, and then we ask them if they're smokers or non-smokers, and look separately at those two categories of people, if we now find that amongst the non-smokers, what we get is that there are many people here with white fingernails and healthy lungs, some people over here with those, and very few people over here, okay? Whereas if they're smokers, we see the opposite pattern. So there are many people with diseased lungs and yellow fingernails, some people here, and a few people here. The idea is that if we add up the numbers in the table here for the smokers and the non-smokers, we get back to this correlated looking table here. Whereas here we could say there is no correlation here, okay? We essentially have just, if they're smokers, okay, I'm just going to appeal to your intuition really that this is not a correlated pattern and this is not a correlated pattern. It's only when we add them together that it's a correlated pattern. But if someone really wants to know, I can explain mathematically what we mean by talking about correlation and not correlation. But I decided just to go with, hopefully, that this is intuitive for you here. Okay, so as I said, I haven't talked really anything about quantum mechanics here. I'm just giving a list of, as I say, what I'm hoping sound like reasonable assumptions to you. Okay, so what we can say is that experiments, which I talked about in my previous talk, experiments prove that at least one of the following must be false. At least one of the following assumptions: that experiences are objective, that causes are in the past, that nothing goes faster than light, that free choice is possible, that correlation implies causation, or that common causes decorrelate. Okay? So one of these must be wrong. Which one? Well, that depends on your interpretation of quantum mechanics, or maybe more broadly on the way you think about the world. Okay? But sticking to the interpretations, so I'm not going to talk about all the interpretations that Ian mentioned, but some of them. So the Copenhagen interpretation, I would say that which of those assumptions does it reject? I think it would have to be the assumption that correlations imply causation. Or in other words, Copenhagen interpretation, you could say, yes, we see correlations in the world, but that doesn't mean that there's anything causing it. That's just the way the world is. Okay? Some people might say, no, there is a cause, it's just that the causes doesn't mean what we normally think of it to mean. Okay? There is a common cause, but that doesn't mean that there's any way we can actually decorrelate those things by finding out more about the world. Just cause, we have to change what we mean by causes. Okay? That's one possibility. So cubism, which is I'm using, so cubism, etc., this is what Ian called participatory realism, or perhaps anti-realism, would deny that experiences are objective. Okay, that was the very first, assumption number one, that experiences are objective. I think that's what it would deny. The many worlds, which Ian said is completely the opposite of cubism, or completely the opposite of anti-realism, would also deny, I think, that our experiences are objective in the way that I defined it, because I said objective in the sense of being singular and not relative, so that a person, like if Ian is doing an experiment and I can't see what he's doing, he is going to get one result and one result only, even if I don't know what it is. Okay? And both cubism and many worlds reject that, but even though they do it in somewhat different ways. So then a whole lot of the other interpretations which Ian talked about, even though they can be rather different in their details, so the pilot wave interpretation, the objective collapse or spontaneous collapse, and the consciousness-induced collapse, they would all deny that nothing goes faster than light. They, I think, would all say that what this Bell's theorem is telling us is that actually something does go faster than light. And that is my final slide. Thank you.
This is for Ian. Copenhagen interpretations is that quantum world and classical world are two different things. So I'm thinking that how did he find that this quantum world and classical world are two different? In which way? Is there any special meaning for that? Copenhagen interpretation na lo ga la gorchana quantum world dang classical world ni de ane thade re de ores thade imba de khogi nge do ba and then de da khongi gi da thade insul kan de res ane thade indang de kan de she songs and de de.
So that's an awesome question, and it's one that every non-Copenhagen thinking person wonders. We don't really know. The Copenhagen interpretation has often been called a non-interpretation because no one's really sure what it's saying, except the people that believe it. And since I don't believe it, I don't really know what it's saying. So the answer is, I'm not really sure how the Copenhagen determines that there's a difference between the two. It's the only example I can think of comes from the movie Star Wars, where Ben Kenobi says, "These are not the droids you're looking for." It's just, it basically takes somebody who asks this question and says, "You can't ask that question, go away." So that's pretty much it.
Copenhagen kindezu kinanglo la ane sedu ki ane rimbada ane suju ngon kamrik bek nanglo shesha ki dinzo dan jigdin siginre ane ngobu ki nelu mezu dinzo ane tsawani ne tade res yach shigir was chaza tade yimba khandes ha ko song se ki tewa dela ane tade yimba dinge killing mes chaza de yimba songza ane nge ki ane deshiga tu mares tade ina ya ane Copenhagen ki ane tanda deshi kyagdan dela killing Quran su ki ane deshi dinge ja digorina ta ke maleni ki ane desu mangbodo tasu mangbodo konzo 상미 콘솔 대화랑 구겨res ane kiranso khandechen hakosons chezata ane ngobutara ke kin jikten di zawani thade res ya ki nezu di ane kiranso khandesh hakosons ya di ta khandesh imba ha ko di nganzu ane pe khariores lana ane enji lonye de nang yewe ki chuma de pe shana ma do pe shaya ras mares ngala chizanga killing mes dagi khalla sona labgi niluk tang ani nyamje ge niluk ni seso seonri kabdela chigla demba mare la so ani labgi niluk de demba la chigi ani nije ge din an denam din niluk dila demba yo mare la so de khande chene ko ani thakse chine dene laudes. Yeah, is for Ian. In your presentation you said that the wave nature is real. But the common experience that observer draws from that wave nature is not real. Did you say that? And if yes, then why did you say that?
I said that, but only about one set of interpretations. So in some interpretations, the wave nature is not real, but in some it is real. I mean, certainly, I'm going to pass it off to Howard for a second.
Okay. Well, yeah, I'm just thinking the one way to give that sort of positive answer to that would be in the many worlds interpretation and related interpretations. The ultimate reality, if you like, is the wave function, which is maybe what the questioner meant by the wave nature. But that's a wave function for every particle in the universe, not just for one particle. So it's a very complicated thing. That's the ultimate... oh, sorry, should I pause and let you translate? No, you can say. And keep saying, okay. So that would be the ultimate reality. And then, so it's not so much that objective experience is not real, but that it is not able to know that ultimate reality. It is only able to reflect a small part of that reality. So it is real in a sense, but it's multiple. There are many of different objective experiences happening, and none of them are really capturing the whole of reality.
Wave functions ane tik na le de lab ki chile se di ane nguyu ni zula yore da yomare ko ane tundam de yowa reda mare sia dila ane yore singi ki ane deshi ganyi ki lug yore tigana shi ane yomaris lanyi ki ane deshi lug yorwas ta ine ya manchi we ki khala yore slavi bena ane kesi yowa jimbe na dembar yowa jimbe na ane labs ki ane neta wave function se lab ki chile sia di chadi yores chana ta lab ki chile di ane yujen kansa tsu ki to yung du zambala ane khonzu ki lo la sharwe ki ane tokpa di ta demba re da demba mare sidu zambala ane jaja jathamba re da mare ne la thoya khakpo chagi yores ta re la ne di yores khachila na lab ki yugul nilu yobe ki nizu 차상 매빈이나 춘규직 거기 안에 돌로 샤르기 여레스 빅 차네 고 뎀바 샤네 디기 여레스 여와치 이나야 아니 유기 내주 차상와세 직 안에 유진 지라바 직 롱을 샤리아 매와 손상 또야 매비 그 gemzen 때네 아니 디 안에 된담 뎀바레스 여와 샤기레스 라야딘데 야 라투 마레스 제자다디 데시 야다 다 소소스 삼노 단조 탄다 제주 망고도 디소스 그 란조 로고 여레스
Good morning, everyone. So here I would like to know, I would like to ask on the waves for question for the Hein, yeah. So how is a particle composed of many waves? The new theory kari is in a chitang the develop color ba. Lab the duten kazuki ku dugi yores ku. But the duten the lab kazuki dugi yores still.
So actually, particles, I wouldn't say particles are composed of many waves. The way we would look at it is that you would have some underlying phenomenon, which in physics we actually refer to as a field, and that field manifests itself either as a wave or a particle. And the particle nature and the wave nature are different ways of looking at the same thing.
제자다 두시야 디 랍 망보 촌네 쇠샤와레스야 딘데키 아니 계제식마레스 제자 아니 랍 루루 차체 초체 아니 두투바 딘데키 계제마레스 먼저 온감세릭 나로 카르게제식레스 라빈베나 아니 네베 라와 시에지 필 시에지 계제식레스 제자 라와 시에 디 카리오르슬라미 베나 코 남규된타 남봉wen타 만주 그타탄 돈 남규된타 마다마다 뛰는 거레스 남규된타 찍라 아니 코 만주 그탄다 랍시에 디 민타기 요레스 남규된타 셴바 찍라 만주 두시에 디 민타기 요레스 이야 카리슬라비 베나 라와 티어랑 차디 요레스 추 타도 윈베나.
All right, and so we have more questions here. Yes, one more question? Thank you. And then after that, if there are questions from the audience, we'd like to have that, so please think of your questions.
다기 둘 치들게 남제 시험에 갑들라 아니 둘 코랑라니 규리게 남제 아니 샤니시 고 기게세서 디운데 갑들 덤보코랑 치들 코랑 마르분데 갑들라 되니 아니 규리게 남자더니 세단 칸데나스
So when I was listening to the presentations, it seems that the concept of a quanta or the quantum is still not clear. But still, in one of the presentations, you talk about the correlations and causation of this quantum phenomena. How you can talk about law of causality of something that you don't really understand what it is?
Yeah, no, that's a good question. So maybe the first point I would make is that, I mean, the correlations themselves are something which we can measure definitely in the lab, and there are no disputes about that. So, in a sense, to use some other language, they are part of the classical world where we feel we understand what it means to make settings and to get outcomes, and nobody argues. The arguments come from, and okay, so that's the first point. Second point, we can predict perfectly what these correlations will be. So the theory is perfectly well working theory in that sense, that mathematically brilliant. that probably doesn't translate, but it's from that point of view, no problem whatsoever. The difficulty comes when you ask what are the causes of that correlations, and that's exactly what my talk was about, to say that yes, we have to say that we can't say definitively there are different points of view about what is the cause of these correlations, or whether we should even talk about cause for these correlations.
Tanji nanglo la tendril se chigda ane junde kin dewa se ni yawa chigduas tendril kin dewa se di ane sedung ngam rigbe kecha mares di suigin ngam rigbe nanglo yore ane tendril kin dewa se di ane nganzu ki ane chi ki namsha ko thone ane thanda she tu yore ngama suigin ngam rigbe gang she tu yore cheza de thola ane kange yo mares 대가나시 안에 던들기 안에 대화디 ngar khar-chungi ba chamayu ba maung bala khandis chungresia di nganzu ngonsu che tu-res chezata kange khwa tu-di yores labena tondekin dewa-di jundekin dewa yimesia di ane del tu-di yores chezata jundekin dewa-di sidung ngam rigbek nanglo la gyuchinye khandis-re ta dika tanda labda di namgyur tuentang khpala gyuchinye khadin dewchinye khadesia dila ane kunzu ki tanda tawa mintuin ba mangbo yungu yore tawa mintuin ba mangbo yewe ku gyumsen tene ane deshi gyakta manda mangbo shungu do 상마 연구 열스기 열스 제가 땅이기 아니 던데다 준데스야디 아니 니주 다 타지 빼된 거야디 니 차디스
And we also had a couple of comments that wanted to have. So, Anil, do you want to have a comment here?
Yeah. So, yeah, I just wanted to make a comment about the non-interpretation or what Ian talked about, the shut up and calculate approach to quantum mechanics. I don't think we want to leave you all with an impression that physicists are just using quantum mechanics to make calculations and ending up with smartphones, which one can argue about whether smartphones are good or bad, but it's also being used, for example, to do biochemistry, to understand how proteins fold, how molecules interact, and this then has direct consequences for medicine and drug discovery. So it's an approach that has enormous consequences. Some arguably you could take a position that they're not very good, but there are some that are directly beneficial to our lives, and yeah, that's something I wanted to say. And then okay.
Da tanda deshi gangi mangbo doa jaza richi ki tanda kharch sigi yorslabi mena ane obe ni lula ane sidung ngam rikbe kharshi me di chudo majis khatsum ne zi gyap se ane mi rikchi yores jaza kunju tawa di tol ngarang ke samju shebim bena ane sidung ngam rikbe nangdu shemba khartung gi yemi di ane ha mago yimbe나 ane 신도 가리 예와 딜라 때제 ane nganzu ki chala mangbo shoji so tu yores chala mangbo nangloni chi kharcha de yores la mena tanda khawa de zo cha de yoros cha ta dinde ri din zo ya re da do re sel khashi ya re sigi yore khashi do re sigi yore so lancho manda sim to chow yores ri chi de khares la vina pe sha mena nganzu ki sugbe ki trubje ki dudu din zo ki la kha che na da dudu din zo gewa drobe ke thone nganzu menju khandes che du gu du sia ane nganzu men so ya da din zo thola tega dewa yore che ta din zo ri khashi ane yakbureda duchares ani keje tv bena duchare lasa khora yo mares chezata dinde ki mewe ki ani nganzu kin thungi sigunre nizu mangbuchi thola ani tanda ani shugin te tu yores.
Let me just underline a little bit about what Anil said for my own self. I'm a shut up and calculate kind of guy, and but I think it reflects what Geshe was talking about earlier, which is that motivation is really a piece of what we do in science, and how we think about what are the ultimate directions of what we do, whether we're designing a plastic bottle, as our friend pointed out earlier, or we're designing a smartphone. But we use quantum mechanics as an understanding, even though we may not understand the ultimate truth about what's going on. We do understand something that helps us use it in very practical ways to think about how science advances ourselves.
Jizanga dindis nga ane khazum ne tsi course ni ki ane tanda langcho simni ki sedung ngam rikwa dindi ji chadi yores is jaza da dinde thone ngi samtu di tanda geshela ki thanasho ki ane kamusunya dida ane dewa chadi yores kechi shu di khares lavim bena tanda geshela ki kuno re laswas jaza ane ngobe ani thadu ne lu kharesia di ani sedu langcho dik to ne she tu me wimbena ya ani tanda kharishimba di peju chebe ko to ne ani nganzu pendo yowa da ani nganzu ki ani music rodang nanglo lo shugyen te to be ke nizu mangbo chi so tu yowa sonza ani pendo yowa ani so tu bu yores langcho dik to ne.
We'll get you next. Why don't we go over there first? Yeah.
I think cause and effect, what we call karma, is somewhat similar to Newton's third law of motion, which states that for every action there is equal and opposite reaction. So I want to ask you that if they are similar, then I want you to put some more light on this, and if not, then what are the dissimilarities between them? And if I am misinterpreting it, then I want to relate it to any theory that you would like to relate it to.
Tanda sidung ngam rikwa nang gyunde ki namsha sungu dwas chizada gyunde ki namsha se dengan zo ki namgi judan diun rotan le se dinde sigi ore tigana shi ane tanda sujing ngam rikwa nang lo yimbe na nitun ki tim sumba di ane gyunde ki dewa ros phajik chebi yimbe na suji yungre se chiza ane di ki gyunde ki dewe ki rotan de da tanda sidung ngam rikwa nang lo shi gyunde ki dewa rotan de chikba rewe thate rewe.
I'm going to attempt to answer. I want to make it clear, I don't understand karma that well. I learned a little bit about it at dinner last night. And we use it, the word is used in the West in a certain way, so I'm not sure how close it is to the original meaning. I can see why you would think there is a similarity between the two. And from what I understand of karma, that might be a good analogy, that it is very much like Newton's third law, which is really a representation of a larger concept known as a conservation law, that certain things even though they change, they really stay the same. There are certain things that are passed on and are always there. And that's kind of what Newton's third law is saying. So I'm not sure if karma is exactly that, but it seems like, from my very superficial knowledge of it, like it might be similar.
Jada tandanganzo karma se nangbik le se dinzu kol nanga shingi mes dagung konda giantis kokab rasons thana shi nobjo do la karma se ki thani de peju shiu chigir de ni mena ane de ki ane khodun de da ane ta nangbe ki ane karma se di ki khodun ngoi ka phalla Kazakhstan yu yeme nga she masons jada ane kesi karma se di ki khodun di ane niba imbenere nezu kari imbene chik ane yewa di mewa cha mandoya ane mewa ji yewa cha mandoya ki dinde ki khodun ji yewa imbena di tanda Newton ki ane tanda tim sumbe ki ane namsha da daw cha du yores jezada Newton ki tim sumbe ki namsha da khares la imbena nuba la sowa ane nganzo nyarza ki tentim se yores ngam serik namlo di ane ko ngo gyurgu yor din imbena ya yewa ni ada ane mewa de sar du chemo ya ki ane namsha ji yore jeza ane chikchine daw cha yesi yores.
예, 나랑게 kubjaga la madese mardewa di hine hakos kubja tumbai gongda jesange di dekheje jamna samso tanda di Newton gi law of motion scenario ta Newton gi sheshawati ta khandar kharse orsana chitang gi medawa scenario tan duje scenario di nangshi di nanglo la gyudan gyulten in division de gi chitang gi the law of nature sina ngupi tendem sina doluk chik chidang yodi yore ti tanda ta Newton da khunji he de che yina nga to nangbe ke tanda le junde se ti chobo chidang ne ni ju chik le ten ni div 7 chitam na de singdung chigre sen ro ju du chu di shi gi yomare khari shi gor sen chidang ge judan divuti nangsu la ene suzu ge kunung dan de ne ene lega yakbo che na ene diji yungres 독자 제체나 미개의 용거래 세진에 그 깨체 희사 기타 찹공 라보디 지단기 good than David Namsha Nala, you're the inner Tandanga to the less left the so the Suzuki Nyowa than Dane, any Deva Dunga Yongsu Dilata, Tona Chegres. Suzuki Migeva Jichena, Dunga Yangradas, Yagujichena, any Jibu Yungradas, that two tigal shake your madog. Timadogi called with the Lungi Javne, any Shingdungi Lomachic House, they lay Junde, this Igo Mare. The Chitangi called that law of nature and Rodan Higormado. So the dignities Yavachet, Kachimbu some. So I was briefly saying that in general there is this context of fruits arising from their causes. So this is the general background. But in Buddhism, when we talk about karma, we are not talking about that general causation. But what we are talking about is cause-effect relationship that is related to human experience. If you do good, you have good. If you do bad, have bad. Because it's related to your own experience of happiness, suffering. Therefore, it is taken very seriously, and you are repeatedly asked to observe the law of karma. Yeah.
Thank you.
So, can I just actually
Yep,
say then,
please
then
go ahead.
I think that is actually it's a good analogy, whether, I don't know if it really means the same thing, but it's a very good analogy.
Jigba jigjang membi imbena ane pedini tahu yores.
Oh, ngana tuwa ni shredo, tuwa dangbo di karensi na di dulden chame da dewa yin. Dulden chame ta ngana su nama sanga je bishung nangla dumta wangma ta wangma kabla kaya chenpo shi chadere. Tende yendo tene kong nambe ta di dulden chame se tegi chechung ji se kandis yore. Di kong nambe tulche ki kwane gyune tong togres. Di tongsul di ngoso tong togere ta yana sobak zam chigere. Di sashi sabaji te nawa ina ngaransu di nangbi ka chumde ka la shebi tene dulden chame se de la kuas ting sabro de dan tene nyeshe timbu chayla pendok chimbu do tengido tiwa sena da di chik ti nipa de la karisena kyaran zuta tserik baji hembi chane samla lo sorne bi chane samla tawa ina 다 먼저 출력 망보여래 낭바 디가 나시 이슈라서 봐 출력 망보지로 대나네 툰 체쇼다 걔나마다 당녀쇼다 어디 가르쳐게 도스 걔나마 로스워네 베고는 공마시 바이나
I have two questions. First one is from as a Buddhist, especially in two lower schools of Buddhist philosophy, the concept of partless particle is very important. So because of that, I would like to ask scientists, when in science, can you observe partless particle directly through using some instruments, or when you talk about the partless particle, is it just a kind of assumption or a hypothesis without really empirically observing that particle? That is my first part of the question. My second part of my second question is, as a scientist, you have a very kind of unbiased attitudes. So if from an unbiased point of view, if you ask what is the religion or the major religion that is closest, that has the closest resemblance of scientific point of view, what is that religion?
Well, I'll just say from my own perspective, I think Buddhism is probably the closest from what I have.
And
I'm not saying that just to be nice. And I think that the way that we think about and kind of investigate questions, and also I would say, partly because, at least from what I've learned from you all and from the readings that I did before I came here, I'm not a Buddhist. I grew up in the Catholic faith and don't really have religion at this time. But I would say my sense is that part of how we think and construct our own understanding of the universe has to do with, are we willing to change that view? And I think this is a critical piece. And I see a great number of religions that are unwilling to change their view. And I know that when I heard the Dalai Lama some years ago, I definitely got the sense of the ability of the Buddhist perspective to have a fluency in terms of looking at how the world, how our understanding of the world is evolving, and evolving our own understanding of that through spiritual understanding. So that to me was impressive.
제가 안에 nga nangbaji mares inaya ane ta kyaran samne nga nezu khashi khoya khokap junior thegana shi nga del mayung ke ngola ane nangbege ane ta tabdinde ane lowins cheza ta di lowe ke ane gumzen la tenis tena nga chunju kaps ane yishure ina tanda nga chulus ke mes nangba di ane siri dan tunche shu re goya res la goya insa res la goya ke gumzen zo de khawa tu du yus la bina chulu shimba zo pechewa ane misusu ki ane nyongwa da dendele tenche nezu mang shin yung du zambala nezu mang shimba di shela shane ane sosu ke samlu di ane gwa tang tu me na tawa den gwa tang tu me wimbina ane di ngaya bore sam ke mindu sina dende ke ane gwa tang tu be ki chadi ane nangchule yosari nangba den zo yosari ngalo khashi ngma konda gyawrum buchi ke ane community konyus ane manzu ane shingmu ke nezu den zo ane mang tu shin mang shin yung du zambala de la pa we ke ane ngaran su ke ane ta jigden sigi ne ane yujing ke tadan den zo changma ane khale del pa we ke ane gwa tang gu res ya ke ane kamusung su cheza dende ke ane gwa tang ke ane nuba sigi ne kolgap sigi ne dip education bores.
So I'm not sure I completely understand the concept of the partless particle, but I guess my interpretation is that this is partly it's the particle wave duality, and partly it could be thought of in terms of quantum field theory, and there are various interpretations there. But I would say that when I think of, but I will just give you the sense of a photon as being the question of whether a photon is localized in space or whether it is has a particle nature to it or a wave nature to it. And so when I think of that, I would say you have a localized wave packet in which there is a variation in the electromagnetic field that exists in a very small region of space. And so that in some senses has to do with its particle nature, but it's not a particle in the sense that it's an oscillating field. So one can take both perspectives, neither one of them is right or wrong, but there are interpretations that help you and guide you in terms of solving real questions within physics.
제자다 디와 당부디 글랜디 아니 다 든든 참여스야 디 계제 시행 두 삼발랑아 든든 참여스야 디기 안에 대시 약주다 코딩 카리메 세오시라 싱네스 이나야다 nganzu ngam tsere knal keje shi yin sambala labdu sungden krangshi labda du ninga ane sungden krangshi yin debe ke ane nezu shi gyores cheza da diladu sambala pecha shana wedul do shimbe na photon se wedul do shimbe na di kotadan chik ne te yin sambala ane ko du keje shi gyore de chik tena lab keje shi gyoros ko yin de khares labin bena ane logdu khablen ke lab ki rawa ane dindeki ane cha chunchunchik ane panangki ane khosa chiraba chik nanglol ne kapsula ngazuk dil khala yores labin bana dusi yores jina da dindeki ane labdi ane pa chitham de kapsula ngazuk dindeki ane rawa di tham de kapsula ngazuk lab lagi yores ko yin ane ko shijik chadi yores jez.
So we had a question back in the back here. Yes, go ahead.
So we had two questions. So first question is that why is Bell's theorem considered the most profound in science? Unlike the other theorems, there must be other theorems too which could be considered the profound in science.
Cheza da tsiri nanglo la tensu se yadine do theorem se yadine and dere mangbo yo shik do was cheza da dere mangbo yo bin bena denzo changme nanglo ne ane chap chishu se yune re ta nubon tenshu ki ane tensul se yadine ane she yo res.
First, I should point out that, so I put up that quote specifically to disagree with it. But I did make the point, okay, so the quote that I endorsed, because I wrote it, was that Bell's theorem is the most profound, what did I say, prediction of quantum mechanics that has been empirically tested or confirmed. So why is it so profound? So the two answers. So one is, well, okay. I made this point yesterday, but I'll make it again. I think the important point is that the Bell experiments do not rely on making any assumptions about quantum theory. no quantum theory at all goes into the tests that we do in the lab and the conclusions we draw. Of course, we have to know quantum theory to design the experiments and to get them to work, but the actual analysis of the data has nothing to do with quantum theory. So the strength of the Bell's theorem and the tests is that we can draw conclusions about the possible natures of the world, which are theory independent. Okay, so we don't have to talk about particles or waves or anything like that. It has nothing to do with the mathematics of quantum theory or any of the concepts we use in quantum theory. It's just we can say, if we see these things in the world, in experiments, which we do, then we know, for example, that one of the 6 assumptions I wrote down must be wrong. And none of the other experiments that we can do are like that. None of them are so, in theory independent, to use the term that we use. Is that answering the question? Was there anything other part to the question? I think, and I guess just why is it profound? Because I think that we have to make a choice of giving up something that seems extremely intuitive. Like the 6 assumptions that I wrote down were meant to feel like, yes, that sounds like it should be true, yes, that sounds like it should be true, etc., etc. But we get to the end and we say we have to give up one of these. And for me, at least, I think that's saying something profound about the world.
I would just add that because Bell's theorem addresses the nature of reality at a fundamental level, that's probably one of the reasons why that original quote came up.
자자다 단지 깨제 디와드 코안레르 슬라빈비나 아니 미심바지기 아니 롱렌시 제소아 아니 벨키 아니 펜술레 세디 아니 세릭 나로네 아니 텐수 아니 타 약슈드레 세키 아니 롱렌시 제소 자자다 겔라 코나 롱렌디 카치니 체인 라빈비나 겔라 코란키 아니 약슈레 세딜라 아니 모네메스 이나야 아니 벨키 아니 텐수디 아니 세두 응컴 리베키 나로 셰샤베키 니주 든조 무슨 그 토니 뇽토비아 요알라 아니 텐토미키 아니 단다 텐수 약슈디 벨키 아니 남샤디 차 벨키 텐수드 차디 요레스 벨키 텐수디 딱지 제베 갑슬라 세두 응컴 리베키 나로 셰샤베키 아니 지금 조단다 대가나시 코란수기 아니 제시 야단 든조 강야 배주치 구야 마레스 배주치 마레스 제가 디 임바송자 theory independence 도 남샤라 마되바 또지 그 룸시디 세베 갑슬라 남샤 나라 칼라도 델레 테지 세요 마레스 제가 뭐비기 네주 남겨 데네지 띵고여나 아니 덴데 그 띵고에 그 gemzen 디 인사레 라체 아니 gemzen 망보지 당소와스 gemzen 저 망보 당 유두 잠발라 벨기 텐수 디 카팅고 여레스 나베면나 gemzen 셴바 창모 노르데와직다 세중응감 릭비 그 당샤베 gemzen 디 고튼 용고여레스 제가 딜라두 잠발라 아니 벨키 아니 녜수 디기 세중응감 릭비키 아니 나로른 제시 작단 디 아니 찹침부 시우주 템바다 대가나시 싱우비기 네준 제시 야베야라 아니 세중응감 릭바다 녜수 디키 아니 타 딜라 하 템tum니 메오 송장 코랑기 탄다 profound lesh to ta chapchimbo da chapcheshu da jacheshu ta thing sabshu reseki and thani denzo dichini pejuchi is.
My question is to Professor Ode only. As yesterday, Professor Arya used the interpretation of cubism and she explained measurement of quantum physics. But today, interpretation cubism is denying that experience are objective. Are these two related or completely different?
Ani kasa ani cubism se ke di ke ani deshi jagdan thone ani sedung kom rek deshi jagdan de she sons cheza tring ani tanda sedung kom rek ke dewa mangbu yewe ke nanglo le chik di ani cubism le shas ina di ke ani nganzu ke ani tanda nyongwa denzo ani ko yula yo dende marese ke ani ke shigi yor sig dus cheza ta di khasan ke shedan da tring shedan de ni ge de yor we yang mena chikba chad yores.
Okay, I'm not sure I understand the question, but I think maybe is asking, yes, so then the slide that's currently up, I'm saying that cubism denies that experiences are objective, and that maybe yesterday when Arya talked about cubism, she said, I mean, like the experience is the most important thing. Or something like that. I think the resolution is that the statement that I have about experiences being objective is referring to everybody's experience. So the assumption one, which I said experiences are objective, was saying not just that my experiences are real or objective, but everybody's experiences are as real as mine. No matter how far away they are, even if I can't see them, even if I couldn't possibly find out what those experiences are, that they are real. And that's something that cubism would deny. I think it would just say, if I have no knowledge about it, then it's just not part of, I'm not going to talk about it. I'm only going to talk about my knowledge, my experience, my knowledge, my actions. It's all about me. I think that's actually a direct quote from one of Chris Fuchs' paper. It's all about me.
tabeje tiwadi dinishin le ingires tedan tringi tamshi nanglola ane cubism sia diki ane deshi jada chebi bana ane nganzu ki ane ka nyongwa sigine re ane yujin ki ane shedo denzo ane yule yo maresia di an konzu klangjo re ina ya khasan ge ari morang khala yor islami bena nganzu ki nyongwa se experience ye denzo ane kechimbu re se keja she yor was chezata di khachinin ge yo mares labi bena ane nyongwa kechimbu mares gi yo mares nyongwa sidu zambal ta ngarang su ki yujin lolan yuki ne su karishemba de dende shiresha de dende yongsa re samya yor was cheza di kechimbu mares gi yo mar di kechimbu restando tanda Christian folk like sirik ba khorang she shagyo chebin bena nga kechi shu nga resia ki ane keja shedan dende she yor was ina da dik nanglo la ane kelingi yo mares sidu zamba khalla yor islami bena kirang ki lo la shawa nangshi kirang za mai ba nga tu chami ki lo la shawa nangshi ane yulu yo mares gi yores.
My question is to Gisela regarding what is the view of Madhyamika on particles? Because I think Madhyamika did not give any views on the particle status. And the second question is a little bit off the track. It's to, the physicists, that where does this antimatter stand with respect to the quantum theory?
Omeki tawa shisha chebin bena ane du se de deshi khanis yer yores nge samba chebin bena omeki shung nanglo la du ki tel mixi ke ane tawa simindu samgi yes di tiwa thangbo di ins gisila la tiwa niwa de khari islami bena thanda nganzu ki ane ngongkham seri nanglo la ane dogdul la chike je shi dosta antimatter se derda chaza on di ane chedu ngongkham rebe ki dumshi nanglo lo yimbe bena shab yimbe na khawale li yores.
So I'll address the first question. In the Madhyamika, particularly in the Prasangika Madhyamika, they never accept a partless particle. So basically saying you search however much you can, you will never be able to find a particle which you can say partless. Ume nalo la dute chame killing mare. Dutamu kasi ma se ne te ne kansam ching ne ta di thasho re chahi che mdu se jawa ni ni mare sila da ta di tingsa ngone chen da cheri na lo ngone chen sigi che bu cha yung yo re khran ju ge chame chi du do ngoma ina di duten sama thuye gi ene duten chi tabe duten chi chame chi go du sel gi yo re ta khase che na ya tik thoyong gi so ro chi thoyong gi so ro chen ta langi chi de de yo ro I'm going
to answer the second question very quickly. So the answer is that the word antimatter is misleading. Antimatter is just matter. It has the same properties as matter. It just happens that when antimatter and its matter counterpart collide, they change form into pure energy, but you could also view that as a form of matter as well. So there's nothing different about antimatter. And in relation to a question that was asked before about whether we can observe things directly, partless particles, whether or not we refer to it as one way of looking at something, we can see individual particles. We do this all the time. You can even do it with a little experiment where you can see cloud trails in alcohol. So.
제자다 탄다 타니 카시 그나론 도둘 시리 카시 길라나 아니 도베기 뱀제 세야디 도과 세야디 긴 타니 디기 아는 아주 갑리 아는 고몽 주요레스 제자 도베기 두다 도베기 뱀제 세두 참발라 뱀제레 셴베기 아니 오부 셴바지 요레스 요 마레스 제자 코기 아니 뉴바데 카조 로가 임바 손자 만주기 마체 시로 탄자 뱀제 세야 디니니 아니 냠도 안 도스키 잉두 참발라 아니 코 뉴베 공고른 교도야다 찍찍파 아니 도베기 아니 차와체야디 지기 요 손자 아니 밍디타르마도 디야 코라 아니 뱀즈uk nanglo pemzek nanglo le digores pemzek nanglo le gi gemzen tene ane ngo chidung khamrik bek namsha nanglo la ane dunchamu chi ki ane todang nang shin che ane za deshe ga tuya cha digores dijik che ane dingona tanji jige desung soas tanda ane dun tarab da dun chamu dinzo ane tarab ke jama ta dun chamu dinzo ane nganzu tsenrik nanglo tegan thong thu yore be se ke jesh duas chezadi ane thong thu mardas ina gyune ane tagu yore special shavi bena kunzuki ane tanda dun tarab da phasha ane dunten khala khansam chembu ingyo dinzo imbena thong thu mar kunzu yowa nganzu khandes taigres lavi bena gyune jeba chigres special shavi bena ane alcohol la nganzu tanda arasi ro cheza dinde ki ane ngobu shemba dinde nanglo la kunzu tangche kunzu dowe ki ane jeg shukjen de chembu shu cha yung yore shukjen de le teche o ta dine chinsha de le du pel du se de shi yore